In this experiment with the pith balls, we will use the Wimshurst machine demonstrated in another video to demonstrate the electrostatic repulsion. The pith balls hang from the stand, which is made of conducting material with a thin steel wire, which is also conducting. When electric charges are transferred to the stand, those charges are redistributed throughout the stand and the pith balls, so that the whole assembly is at an equipotential. The pith balls are also coated with a conducting powder. The video will show shots from two angles. The second shot can be used to observe the device charging the stand. Even after a short turn, enough charge transfers to make the repulsion evident. And now, as we continuously turn the wheel, trying to achieve the maximum possible voltage, this is the separation scene. The sharp corners in the new attached part of the setup leak charge, so the highest voltage that can be achieved is limited compared to Wimshurst machine operating alone. And in case the sign of charge matters, we are reversing the charge. I don't trust the labels there too much, but we are reversing the sign of the charge with which we are charging the stand and the pith balls. Again, even a short turn transfers enough charge. And this is us trying to achieve the maximum achievable voltage in this setup with the sharp corners leaking charge. And yes, it is painful. You can use this shot with the ruler to calibrate the length scale. Let me show that with the centimeter scale with 0 on the bottom. You'll need the length scale to calculate forces and other things.